Okay, finally, here we are ready to go back to coding up our little game prototype, which is what we're really here for, right? Well, a common place for someone to be at this point, having learned all of these C# concepts about classes and fields and methods and so on, it's common for people to think at this point, great, I know the basics of all these things, but how do I use that knowledge to then open up Unity as a blank slate and turn my ideas into a game? How do I know what to write when I find myself staring at an empty mono behavior script, for example? Well, knowing the general C# details is one thing, but you also have to become familiar with the particular classes, fields, and methods that have already been written by the Unity developers that give you access to the Unity engine itself. So basically, you have to use what you learned about C# in order to understand, at least on the surface, the purpose of code written by somebody else, which would be the Unity Engine API. So Unity as an API, or framework, means that since it has a pre-built set of classes, properties, and methods, you can't just write whatever structure of classes, properties, and methods you so choose. You have to learn how to make everything play nice within the framework. And most of that is simply learning through documentation such how to use the existing code within the framework. So that's where pretty much everyone has to start, with better understanding the Unity API. In this video, I'll be showing you what it means to sort of wade through the API and how to generally go about researching those classes, fields, and methods that are available to you in order to use to create pretty much any behavior you want in your game. So in order to look closer at the API, let's refer back to some of the code we've already written and see how we can dive into the Unity code base from it. So to better understand what makes up a game object, in code at least, let's right-click on Game Object here where there's the cube reference field that we wrote before. So right-click on Game Object and we'll see two options we'll be interested in right now, and that's Peak Definition and Go to Definition. First, I'll select Go to Definition. You see it opens up a window that actually takes you to the game object class definition. Now, you don't get to see all of the code that makes up this class definition. In fact, because the Unity code is proprietary, you won't get to see any of how Unity's code actually works, but you will still get a wealth of information that can better help you understand what's going on underneath the hood. You have some comments as well as what fields and methods the game object here holds. For instance, you'll see here the first three members of this class are actually methods. We know that because right after the name game object, in this case, you have the rounded parentheses. Again, we can't see much, but we can see the name, the accessibility, as well as its input parameters. Now, actually, these first three methods are special kinds of methods called constructors, but we're not quite ready to talk about those just yet. And under those methods are a bunch of fields. Actually, not really fields, but rather variables that are just like fields in most ways, but are slightly different and called properties. We haven't talked about properties just yet, but basically they're exactly like fields, but with an important distinction that actually isn't that important right now to understand just yet. Just know that when I say properties, basically take it to mean fields, as we've come to understand fields, until we talk about properties a bit later. Now, we know that these are properties rather than fields because of the variable. After the variable name, we have the get and set keywords. Some of these just say get, others say get and set. Well, that will all become explained later. So we see that a game object has a bunch of basic components of different types, but recalling inheritance, click on the transform property, and actually right-click on transform as the type and go to its definition. And you'll see that transform inherits from the component class, which makes sense as we know transforms are a type of component. So this as well is a component. I'm going to press the back button now so we can go back to where we were. So after that transform property in the game object class, you have a whole bunch of more methods available to you. And yeah, a lot of this won't seem all that useful right away, but it at least gives a glimpse into what the game object class is made up of. Eventually, you'll become familiar with many of these properties and methods, but don't worry, you don't have to actually memorize anything, at least not that much. So, Okay, moving on. We also see that game object directly inherits from class object. And from what we learned about inheritance, we know that means that this game object class actually has a bunch more code that you don't see here. You know, more than just all of this stuff, but also the stuff that it's inheriting from the object class. So what do you think we can do to see that code? That's right, we can right-click it and check it out in the same way with go to definition. And here we go. Here's a bunch more code that all game objects have access to, because all game objects are also at their base objects. And we see that this object class doesn't itself inherit from anything else. So it's nice to know that this is as complex of inheritance as it gets for game objects. So once again, understanding inheritance structures just by looking them up in this way can eventually be very useful when coding in Unity. So just try to keep that in mind. So a quick side note, you may recall in the previous video on polymorphism that we said all classes inherit from the most basic C# class called object. That is actually a different object class from this one. I know that may seem terribly confusing, and you may wonder how that's even possible, since you can easily confuse, the lowercase o object with the uppercase object. Well, we didn't talk about namespaces, but we see here that this object class is part of a containment structure called namespace Unity Engine, right? The C# basic class that we looked at in the previous video with the lowercase o comes from the namespace system. And this is perfectly okay in the same way that a wizard and knight can both hold their own weapon with the same name for the field. One of them is really something like wizard.weapon, you can think of it that way, and the other is really knight.weapon, basically. And by the same token, the object that is from the C# .NET library that we just saw in the previous video is actually of system.object, whereas this object in the Unity Engine namespace is actually Unity Engine.object. Now, we didn't use the full name references, so how do we tell them apart? Well, you can use the full name, as I just mentioned, system.object or Unity Engine.object, or as in the previous video, use the lowercase o object alias, which, as it implies, is sort of a fake name that refers back to the actual class name system.object. You may have noticed that other types are alias too, like int, string, etc. The actual class name for int, for example, is int32. So think of it as a nickname when your real name sounds kind of ugly, all right? That's what aliases are all about. Now, going back to the sphere controller cube reference, let's see with Intellisense all of this code we've seen in those classes reflected with Intellisense in real time. So if I type in after cube reference, which I can't do it there, excuse me, I'll just start typing it again so I can use Intellisense. It opens up Intellisense, and as I scroll through all these options, you may recognize these properties and methods that we just saw in the class definition. So as you probably noticed, these wrenches, those refer to properties, and those pink boxes, those are methods. So this is basically everything that a game object has access to that you can get to with a dot accessor. And you do get a wealth of information through Intellisense. If you click on a particular method, it'll give you a little blurb as to what that method is all about, and it at least gives you a hint if you've never seen it before. See, this one says adds a component class of a component type to the game object, right? Makes sense in that case. Okay, so in our prototype game project, we primarily worked with the transform component. And that component is accessible by a property available to all mono behaviors. So let's right-click on this transform property in the cube controller right here to see where it comes from, right? Where does this transform property come from? After all, it may seem kind of magical. There's no original type declaration. There's no transform uppercase T and then lowercase t transform in our class that we wrote here, cube controller. So where does it come from? It must be inheriting from somewhere. So think about that. remember all of our scripts attached to game objects must inherit from mono behavior, right? So when we right click on the transform property, it shows that it's a property from the class. What class is it? Component. Maybe you expected it to directly be inherited from mono behavior, right? As our sphere controller inherits from mono behavior. Can you venture a guess as to why we have access to this property? Well, basically that's because the script we're writing is, as you see here, a mono behavior that is attached to a game object. Things attached to game objects are called what again? That's right, a component. So that's why this class has access to that property. This transform came from the component class. And we can prove that this script is a component, not only because we know it is in the inspector, but by navigating the inheritance hierarchy. So if I right click mono behavior, we see that it inherits from behavior, right? And if I click on behavior to go further down this inheritance structure, we see a behavior inherits from a component. And once again, if you go to component, look at all these properties. Among them is transform, right? You have others available too. See, there's one called animation. And so I know that I can type in animation because a mono behavior is a component. My sphere controller is a mono behavior. So I have also an animation property. There it is. And we can do with that whatever that gives us access to. So that's, again, why the script we're working on has a property for transform. So how do we know what this transform property relates to, though? After all, it could be referencing any transform. Well, let's see here the note we get from Intellisense when we hover over it. The transform attached to this game object. Null if there is none attached. So we know that the transform attached to this game object is the one we saw in the inspector, right? For the cube. In this case, we're looking at the cube controller. So for the cube controller script, that transform, again, refers to the transform of the game object that this cube controller script is attached to. Now, this may seem confusing. Didn't we just see that game objects have transforms? But so do components. Why? Why would that be? Well, it's basically just flexibility coming, from multiple classes having a containment reference to their own transform objects. So basically the moral of the story is you have a bunch of different ways. Unity gives you a bunch of different ways of accessing common properties like transforms and whatnot. So we don't have to stop there. We can try to understand what makes up transforms better, right? So what can we do? We can find the transform class, or we can just type it in anywhere. That's the class. Don't confuse the property from the class. That little symbol means it's a class with the uppercase T. And you'll also see it color-coded like that. Classes get color-coded this kind of, I don't know, what is that, teal, light blue kind of color. And you could right-click on the class. And this time I'm going to go peak definition. And what happens is it just opens up a nice little inline summary, which is the same thing, but it's just inline with this document. It doesn't open up a new document tab. And, well, it's a little bit hard to look at on this monitor, so I'm going to go back to definition. And here we see what transforms are made up of. Here we see the familiar position property, right, that we've been quite familiar with. That's a vector 3. And so we can just ask ourselves, what are vector 3's made up of? Well, let's go to definition. There's a vector 3. Now, you see here, it's actually not a class, it's a struct. I'll talk a little bit more about structs later. It's really a simple distinction between classes and structs, and actually you'll be mostly just writing classes, not structs. Referring back to the video where I mentioned the difference between value types and reference types, basically this is the difference. Classes are reference types and structs are value types. So structs are just like classes, but they're value types. And there's some good reason for using structs versus classes, but you don't have to worry about that, certainly not anytime soon. So once again, in vector 3, we see some familiar properties. The x, y, and z properties, for example, that we'd worked with already, that are floats. And recalling that we can expand these definitions and get some more information through the comments provided to us. Sometimes it's more helpful than other times, but at least you can dig a little bit if you want to. So looking at the Unity API in this way, kind of going on a little Easter egg hunt and opening it up and finding out how it's all comprised, is useful in a lot of ways. It gives you a way to look at various possibilities while you're coding on the fly, but it also lets you zoom out and see all these class relationships, all of these ISA and HASA containment structures, hopefully giving you a better wireframe understanding in your mind of how all of these classes relate. So going back to what we saw by navigating the Unity API, we saw that, what did we see? We learned that a script class is a component because mono behaviors are also components. A component has a property called transform, which refers to the transform component attached to the same game object as is this component, which in this case is the script that you're writing in, sphere controller, cube controller, and so on. And transform in turn has a vector property, a vector3 property called position, which has x, y, and z properties, which are all floats. And that's why in your script component that you're writing in right here, right? This script component is sphere controller. You can write in anywhere there and have access to all of these properties because your script is a component, and by virtue of being a mono behavior, it's a component, so you inherit a ton of functionality just from being a mono behavior alone. This gives you lots of different ways of manipulating game objects in your game. That's the primary purpose of mono behaviors. So that's really handy. Unity's giving you all of these properties and methods already furnished and hooked up in your scripts directly from just being a mono behavior. But even more broadly, you get even more stuff available to you through the general Unity engine namespace. Remember, we talked a bit about namespaces. Using our limited understanding of that, we can basically understand it as importing the entire library of code that makes up the Unity engine. So let's look at the entire Unity namespace, Unity engine namespace / library. That's what it's giving us that we've already worked with. What do we get? We got, of course, random. Where's that come from? Let's see. Comes from Unity engine. That just gives us randomization methods and properties and such. Like range, that's what we use to get a random value between a range of floats. We got the game object class, of course. Well, you might notice that these are static methods. This instantiate method that comes from game object is static because we're referencing the instantiate method directly through the game object class. We don't need an instance. Same with destroy and random.range. We have a vector2 distance, which is basically the same as vector3. Just all we need is x and y properties with that. We didn't need I think we used that for calculating the distance. Yeah, so we only looked at x and y. So that's why we use that. And we have the getKey method from the input class, which handles, this is a class that comes from Unity Engine that basically manages inputs, whether from the keyboard or from a game controller, that you can then access in your code and create behavior, as you saw earlier on when we were coding up this project originally. So directly digging into the API through things like Intellisense and looking at class definitions, it can be very helpful, but sometimes there's really no substitute for actual documentation, and Unity is pretty well documented in this regard. You can access the scripting documentation either online through a browser, for example, or even directly within Visual Studio, which opens up the documentation stored locally on your computer. I think it's in an HTML file or something like that. And the online scripting documentation is pretty much exactly the same. So yeah, accessing the scripting documentation is very helpful. Also helpful is researching for answers online. There's plenty of forums and blog posts and people talking about Unity and how to solve problems. And it's very useful, but bear in mind that 99% of finding the right answers on the web is knowing how to ask the right question. So I think it's natural for newcomers to not worry too much about getting all of the lingo when learning how to program, properties, fields, methods, static, public, private, all that stuff. But it really helps when you need to ask a specific question and be able to narrow down the field of possible answers. So keep that in mind when learning all these funny sounding terms, that it is useful eventually understanding what they all mean. But even with all this information at your disposal, I don't expect you to now be able to go, aha, I know exactly how I can create this gameplay mechanic. That insight comes ultimately with time and familiarity with the API and just picking up tips and knowledge through the documentation and online and your own just playing around. Half the fun is just playing around and seeing what you can come up with. So simply knowing all these bits of documentation, it's not going to get you from A to Z, but you'll at least know where to turn to better flesh out your understanding and solve some problems on your own and ask questions that you know how to ask and get some answers that hopefully will answer those questions. And there'll be many instances in which we'll be turning to that documentation for clarification in coming videos, but right now I just wanted to show you how to access the API in a variety of different ways, understand it, and be able to use that information to move forward in programming a game. All right, so I'll see you in the next videos.